Hi guys, this is Pratik. Welcome back. Welcome to Physics Simplified. This is the second video on communication system and we will end it here. So guys, I will stand here. In this portion you will find all the three pictures which are relevant for you guys from the previous video, and here we will understand what are the various important terms that are there to understand a signal being transferred from one point to another point. We saw a macroeconomic picture of that. We also understood how signals are produced and how signals are received by the receiver and produced by transmitter, obviously. Okay, and you would find the usage of your transistors in transducer, which is used to convert the the messages that you write or type or say into your electric form. And okay, so if we talk about signal, the signal is not made of any one frequency. It is generally a range. So suppose some radio is broadcasting say 98.5 FM or 98.4. So I would say this range would be ranging from 98.4 FM to 98.6 FM, obviously depending on the least count of the instrument, but there will be a range. So signal is spread over frequency, and there will be a noise addition as well when it is being transferred from one point to another, and hence there will be some distortion as well. So that happens, Attenuation is basically the loss of strength of signal. Probably it encounters the atmosphere or some other form of electromagnetic waves. There might be some sort of an interference which is happening. So that leads to attenuation. Range is basically the kilometers over which the signal has a strength to go over. So I would say this is a 100 kilometer signal, so it will go over 100 kilometer range. The frequency bandwidth is there, so each message signal that you write is being allotted a frequency, and so if you see the telecom ministry, when it allocates spectrum, they allocate spectrum in a range, because then when you get a range, so suppose for certain technology, the range is from 50 megahertz to say 100 megahertz. So I have got this 50 to 100 megahertz of range where I can allocate individual frequency to individual message signal. So that's my limitation there. That's why any tower, sometimes when there's very, if every tower is designed for certain amount of bandwidth. Now if n number of users are using mobile phone for a certain tower, if it is within the capacity, it will take, and there will be no signal distortion. But suppose number of people tremendously increase in that area, suppose some conference is there or some thing has happened where a lot of people have migrated at that place for certain point of time for some meeting or something, then in that case the signal allocation would not happen properly, and the certain users would not be able to carry out the transaction. So that's what signal, that's how signal is being given a frequency bandwidth, and every player gets a frequency bandwidth, and accordingly it allocates individual bandwidth, small bandwidth to each message signal, and hence the limitation is there. But just imagine that's huge, it's already very huge, so it takes a lot of users. Modulation is required because so modulation happens in a two-way. One is amplitude modification, which is famously known as AM. You must have seen AM radios, and the other is FM, which is frequency modulation. So if my signal is of less than 20 kilohertz, it would require an antenna of greater than 15 kilometers, which is even almost double the height of Mount Everest, which is not possible for us to do. So definitely this frequency has to be jacked up, has to be improved so as to get carried in the signal in a form of signal, and the estimate for 1 megahertz is around 300 meters. That's also very huge. So probably you would want to make into 50 megahertz or 100 megahertz of a frequency, and that is done by using a carrier wave which might have a higher frequency, right, as well as higher amplitude, depending which modulation you are doing. And in both cases, if you increase the amplitude, your energy increases, and in both cases your energy increases, right? It's able to get carried for a larger distance. Effective power radiated at this rate is proportional to L by lambda whole square. This is the L is the length of an antenna, and lambda is which wavelength is trying to catch. I think it's very irrelevant, but I just put it because it was there in the NCRT, right? So let's understand now two things, guys, which are important to understand. One is this carrier wave, what is the calculation, how the wave looks, and I'll remove this now. And second, you can see the earth. So if LOS has to happen, like light of sight communication has to happen between two towers, in that case what is the height of tower for a certain range? That is simple mathematics that we will see. So these two things are important. So let's begin here now, guys. This is a carrier wave, and this is a message signal wave. If they were to be superimposed, they are superimposed in a manner which is so the resultant wave becomes AC plus AM sine omega mt. This whole becomes an amplitude of the function sine omega ct. This must be done using a sort of combinations of various LCR and semiconductors. So I don't know that how it is done physically, but it is done, and this is how it looks, the resultant. And if I open this up, this becomes AC sine omega ct. This becomes one wave. Another wave comes from these two. So this is AM sine omega mt and sine omega ct. This can be expanded. Also, guys, modulation index is less than 1, which is given by AMR by AC. So amplitude of the message signal should always be less than the amplitude of the carrier wave, so as to avoid distortion. That is also a ratio that we have to use. So I will write AM in terms of mu AC, right? So I'll write this as mu AC, and this is I divide by 2, multiply by 2. This becomes 2 sine A sine B, which can be expanded. So this whole becomes this above this one plus mu AC by 2, and this is cos A minus B by 2, cos A plus B by 2, right? So cos A minus B, if I do omega C minus omega M T by 2 minus cos this plus this by 2. Am I right? Cos A minus cos B is 2 sin A. It will be like, sorry. There will be no 2. This is cos A minus B minus cos A plus B, omega C plus omega M into T. Now this is a combination of 3 waves now. One is this wave, another is this wave, and third is this wave. The frequency of which I have plotted here, and the amplitude of both also plotted here. So these 3 equations, 3 kind of waves get formed, and these 3 waves, effective 3 waves, travel across with an increased strength, increased amplitude, and they get traveled to a larger distance. Okay, if I want to know the height of what should be my height of transmitter and height of the receiver. So this is let's consider this to be a receiver, this is to be a transmitter. The line which I'll touch these two, I have to find the minimum heights, right? So I'll touch it in a way that is tangent. Since it is a tangent, I draw this as a perpendicular. This is my radius, this is my HT, this is my HR, this is my radius, this is my radius. So in any triangle, suppose this is a triangle, I want to find out, this is the DT and this is distance of a receiver. So if you apply the formula, so right angle Pythagoras theorem, so HT plus R whole square, I'm talking about this triangle, is equals to dt square plus r square, guys. If I open this up, r square will cancel, so this becomes ht square plus 2htr is equals to dt square. This term is neglected because the radius of the earth is 6,000 kilometers and the height of the transmitter or receiver could not be more than 50 meters. So in that case, I can definitely neglect this term, and my dt becomes under root of 2htr. Similarly, my dr will become, if you do calculation, 2hr into r. Right? So if I want to find a distance between these two, I will add these two. So under root 2r will come out common, and under root ht plus under root hr will be there. This is the range, right? This is my range, basically, which we talked about. What is the range from signal top point to signal other point? The horizon is like that. That's why this is calculation like that. Now let's try to plug in the value. So 2r, this is 2 into 6,006, the radius of the earth is 6,000 kilometers. Let's take 6,000 kilometers, 10 to the power 6 meters, right? Under root, this becomes under root 12 into 10 to the power 3. Under root 12 is approximately 3.5, let's take, so 3.5, and this becomes 3,500, ठीक है, multiply by under root ht up under root hr. So suppose the height of the suppose you have made a receiver of say 10 meter height. 10 meters is how much? So 33 foot, 3 floors. Yeah, you can make 10 meter height. So suppose both are of 10 meter. Okay, in that case, under root 10 will become 2 into under root 10, which is 7,000 into under root 10, which is 3.3 approximately. So if I multiply this will become 23 and 000. Wow. So this is 23 kilometers. That's it. So if I have taken 10 meter of height of meter, which is like almost 3 floor height, I am getting 23 kilometer range. Well, that doesn't sound good. Obviously, this is for I don't know. I should be getting more. Maybe I did some miscalculations. Say 33 into 7 is 230 itself. Okay, one more zero is there. Okay. That's a relief. 230 kilometers. Oh, now it's a relief. So 230 kilometer is what this. If I take two height of one receiver, one transmitter of each of height 10 meter, which is almost equivalent to 3 floors of your house, general house. That height, it will cover 230 kilometer of range, which is like seems fair calculation, right? So this is how you calculate, guys. And with this note, your communication system ends, and I have in a way concluded everything. I have taken your learning from LRC circuits to Maxwell equation, to your understanding of wave, to your frequency, to your understanding of nuances of a wave, amplitude, omega. So this, if you have understood each and everything in this video, your concepts are definitely clear. If you have not understood, then probably 20% is my fault, but 80% is your fault, because probably you don't have the coverage of all the concepts in your mind. So definitely go watch the videos. I have covered everything in my videos. So communication system ends, guys, and next and the last will be your Einstein special relativity. Why special? Because it talks about inertial frames only, not in a non-inertial frames. That is general relativity. You will definitely talk about the space-time continuum as well, and it will be an interesting video. And Mr. Panda and Isabel and Mowgli, for the last time, they'll come together, and they have done something brilliantly in their life. Let's see what brilliant they have done. So that will be the end of theory videos for whole physics. एंड मिलते हैं गाइज, टाटा बाय बाय, टेक केयर, सी या।